Hello boys and girls, today we're going to be working on 7.11 and you can see the question that you're going to be answering here today, so take a second and read that to yourself. Okay, so let's get started. Okay, boys and girls, to warm up this afternoon, this morning, whenever you're doing this, we're going to take a look at the in and out tables. So if we look at the first in and out table up here, we're going in with 0, out with 0, in with 1, out with 6, in with 2, out with 12, and in with 3, and out with 18. So take a second and think about what you can do to figure out what the rule is for this particular problem. So if I look at this one here, 0 in, 0 out doesn't tell me anything. 1 in, out 6. I see that the difference there is going to be a 5. But I'm also thinking, okay, let me think multiplication. 1 times 6 is equal to 6. So I'm going to leave those two there, and I'm going to go down to the next one. 2 plus 5 equals 7, so 5 is now out. 2 times 6 equals 12, so times by 6 works here. So then I come down here to the bottom, and I have 3 times 6 equals 18. So consistent for all three of them, my rule is going to be multiplying by 6. Let's take a look at this next problem. Starts the same way, in 0, out 0, in 5, out 1, in 10, out 2, in 15, out 3. So my numbers are getting smaller, so I've got to think subtraction maybe even division. So take a second and think about this one. Okay, so the first rule here, 0 in, 0 out, that doesn't tell me anything. In 5, out 1. So that one could be minus 4, or it could also be dividing by 5. The next one is 10 in, out 2. That would be minus 8 and divided by 5. So the subtraction ones are out. And the last one, let's just check. 15 divided by 5 does indeed equal 3. So my rule here is dividing by 5 to solve that in and out function table. Here's our math message for the day, and let me read that to you. It says an airplane traveled 480 miles in 1 hour. If it traveled at the same speed for the entire hour, how many miles did it travel in 1 minute? Gather your thoughts, and in the box that's going to pop up here, let us know what you're thinking. How could you go about solving this problem? What I'm thinking here is that I can take this 1 hour, that's right here, and I know that that's also equal to 60 minutes. So I'm going to replace that with 60 minutes. And now what I should be able to do is take my 480 miles and divide it by 60. And the reason I do that is because there's 60 minutes in an hour, and my problem is asking me to find out how many miles did they travel in 1 minute. So I know that 60 goes into 480 how many times? Okay, if you said 8, that's correct. So what does this 8 represent? This 8 represents miles. So in 1 minute, this plane is traveling 8 complete miles. Now that we looked at our math message, I'd like for you to turn to page 264 in your math journal. Once you turn to page 264, I want you to study this table right here in problem number 1. What information are you getting from it? Does it relate back to our math message at all? If I look at my headings here, time, minutes, and distance, miles, it's telling me that in 1 minute, the airplane traveled 8 miles. In 2 minutes, the airplane traveled 16 miles. In 3 minutes, 24 miles. In 4 minutes, 32 miles. So what you should be thinking of here is the rule. What is the rule for the time in compared to the time out, or in this case, the minutes compared to the miles? So if you realize that we're multiplying by 8, 5 times 8 is going to put what number here next? Hopefully you're saying 40. So if we could add one more number to this chart, we're going to add a 9 this time. So add a 9 into your chart there, and you've got to think, okay, it's not going to be 48 because that would be 6 if that was in the minutes. So you're going to take that 9 and you're going to multiply it by 8 to come up with what number? 72. So our rule for this particular problem is time in minutes is equal to distance in miles. And I want to remind you, boys and girls, that yesterday you did work with patterns. Today you're going to use tables, rules, and graphs to extend patterns to larger values. You're also going to use these patterns and information and graphs to solve real-world problems. So you'll have an understanding of, this is why I'm doing this, and I need this for my future life. This last part in question number 1 is going to deal with this ordered pair for letter C. Notice here that you have an x-coordinate and a y-coordinate. And that can also correspond to my ordered pair over here. So let me give you the first example for this first line. It's going to be the ordered pair of 0, 0. I'll do the next one, 1, 8. Can you do the remaining ones? For here, and here, and here. Noticing that this one came from over here, and this one was right there. Okay, so the rest of your ordered pair should look like mine. I have 324, 432, 540, and 972. So we completed part number 1 of this problem. Now I've got to come down to number 2, and the direction says, plot the ordered pairs on the coordinate grid on journal page 265. Connect the points with a straight edge. Does a straight edge have to be a ruler? Not necessarily. It could be an extra piece of paper laying around. It could be the side of a math journal. It could be the side of the spine of the book, but you don't want to make sure you don't draw on the book. So think about that and go ahead and plot these points now on page 265. Here we are on page 265, and before we start graphing, I want you to take a notice of a couple of things. Down here in the bottom right-hand corner, you realize that this is the x-axis, and that is going to correspond with what from the table on the previous page, page 264. You're correct if you said time, the time in minutes. And over here on this side, we have the y-axis, and that's going to be represented here, as it indicates, by the distance in miles. So what else do you notice about the numbers? Okay, in the minutes down here, it only goes to 10, but all the way up here in miles, it's going to go to 90 at the highest. And just as a reminder, this 0, 0 point here, that is referred to as the origin whenever you have a number grid like this. Now, my last question for you is, can we use this grid to plot all of the ordered pairs for the traveling airplane? How do you know? You're correct if you said that the largest x-coordinate is 9, and the x-axis extends through 10, and the largest y-coordinate is 72, and that y-axis extends all the way through number 90. Go ahead now and start plotting the points, and I'm going to do the same thing. Looking back at the table, my first number was 0, 0, so I put that on the origin. My next one is 1, 8, so I have to start here on the x-axis at 1, and I have to go up to 8. So I have to figure out what each of those little lines represents. So I always start with 1, 1, 2, 3, 4. That wouldn't work because 10's right there. My next option is to count by 2s. 2, 4, 6, 8, 10. So definitely indeed. So this right here is going to be my 8. My next one is 2, 16. So I move over on the x-axis to 2, and now I have to move up 16. So that line's 10, 12, 14, 16. So what does that 2 represent? If you said minutes, you're correct. And the 16 represents the miles it traveled in that particular time. So it traveled 16 miles in 2 minutes. My next one is 3, 24. And the last one I'm going to do with you is going to be my 432. So there's 4, and here's 32. So what I'd like for you to do is plot the next 2, and that is 5, 40, and 9, 72. So there you can see I plotted my last 2 points at 5, 40, and 9 all the way up there at 72. And the last thing you have to do is you have to connect these dots, and I'm going to try the best I can with my digital ink by drawing a line that goes through the origin or through the point that goes, and it's going to go straight through. So watch here. Let's see how connect them the best I can. And then I have to make a line that goes through there, and I have to make a line that goes through here. So there we have it. There's our graph for that airplane that traveled. So you can see that it traveled 9 in 9 minutes. It traveled 72 miles. If we really needed to, we could look a little bit farther at this graph, and we could see that in 7 minutes, I'm going to run up to where it meets it. I'm going to put a dot right here. And that tells us that in 7 minutes, it traveled 50, 52, 54, 56 minutes. If I did it one more time at 6 minutes, go up to where that meets the line, and it meets it right there, so 48 minutes. So in 48 miles, it took 6 minutes to do that. So just because the points aren't there doesn't mean that you can't find other data points to go with your graph itself. So thinking about those extra points that I put in, the blue one and the red one, does that fit our rule by multiplying it by 8? 6 times 8 equals 48, and sure enough that blue dot does equal 48. And the red dot, 7 times 8 is equal to 56, and that indeed does equal 56 as well. Let's try it one more time with the 8. So I know that 8 times 8 is equal to 64, so let's check that one, and we'll make it a black dot. So 8 times 8 equals 64, and that is indeed on the 64. And let's come down here for a second. My line's not the straightest down here in the bottom, but you could do it down there as well, and you don't have to even go all the way to 1. You could go half. So half a minute is going to take us in the middle there, and we're going to go up to 4, and it should be right about there. So in half a minute, it traveled 4 minutes. And does that make sense with our rule? Yeah, most definitely. 1/2 times 8 is equal to 4. Okay, now we need to finish the rest of the page on page 264 using the graph that we used from page 265. So how far did the plane travel in 2.5 minutes? So looking at the chart at 2.5 minutes, it's somewhere around here. So I'm going to run up till I get to that, and I can see that that's right about here. So that tells me that in 2.5 minutes, the plane is actually going to go 20 miles. So you can see I wrote 20 miles there. For question 4, it says about how many miles did the plane travel in 5 minutes and 24 seconds. And they give us a hint here. They tell us that we can convert that to 5 2/5 minutes. So let's look at that page and let's see. Okay, so looking at 5 2/5 miles, it's going to be right about here. So I'm going to run all the way up here. And I'm going to come up with anywhere from 42, 43, 44. It's probably going to be right about there, which is going to give me 43 miles. So for 5 2/5, it's going to be about 43 miles. And Mrs. Stam and I will give you one way or the other. So we'd give you 42 or we'd give you 44 on that one. Okay, so for 5 2/5, again, it would be 43 miles. Question 5 says about how long did it take the plane to travel 60 miles? So this time, instead of looking at the x-axis and the time, we're going to come up here to the y-axis. We're going to start, because it's asking for 60 miles, so we're going to go to 60, and we're going to run all the way across until it hits that red line. And then what we're going to do is we're going to come all the way down, so it's in between the 7 and the 8. Because it's directly in between the two, it's going to be 7.5 minutes to travel 60 miles. Okay, so how long did it take for 60 miles? It took 7.5 minutes. I'm going to abbreviate minutes for min. And the last question on this page is how long did it take the plane to travel 64 miles? So let's take a look at that graph one more time. So looking at 64 miles, I have 60 right here, 62, so about 64 is right there, and I'm going to run my finger all the way across, and it's going to land right there, and I'm going to go straight down, and that's telling me that it took 8 complete minutes for that one. So 64 miles in 8 minutes. If you think about all these numbers, and we thought about our rule of multiplying by 8, we could also do this with simple multiplication. So if I look at number 3, I have 2.5 minutes, and I'm going to multiply that by 8. Think about what we learned earlier in this unit. I'm going to take this fraction of 2.5 and make it into an improper fraction. So 2 times 2 is 4, plus 1 more is 5. So now I have 5 halves times 8 over 1. 5 times 8 equals 40. 2 times 1 equals 2. I know that 2 goes into 40 20 times, and that does indeed match this one here. How long did it take the plane to travel in 60 miles? We would do the same thing, except this time what we're going to do is we're going to divide 60 by 8. So for this one, I'm going to do 60 divided by 8. I know that 8 goes into 67 times. That equals 56. And I have 4 left. So that gives me 7 4/8 miles. But I can reduce that or simplify it into simplest form and get 7.5 miles. So you could have used the graph, or you could simply continue to use the table and plug in the in times and the out times if you know that the rule is multiplying by 8. So 2 different ways to solve these problems. Here we are on page 266, and important to read the directions here for this one because it tells us that Andy earned $8 an hour. The rule, they tell us, number of hours worked is times 8, and that's my earnings. So our job as learners is to try and figure out what is going in this Y, or this earnings table here, if we know that he's making $8 an hour. So 1 hour is going to give us $8, 2 hours is going to give us 16, 3 hours is going to give us 24. For this one, 8 goes into 40 how many times? That hopefully is 5. And the last one, 7 times 8 is equal to 56. So remember, these become our ordered pair that we're going to go over into here. So go ahead and take a second and complete those 5 ordered pairs. So there you can see that my ordered pairs are coming right out of the table. 1 8, 2 16, 3 24, 5 40, and 7 56. And the last thing that we need to do now is we need to come down here to this table, and we have to, this graph, sorry, and we have to plot those 5 points. So go ahead and take a couple of seconds and go ahead and plot those points. And when you're finished, use a straight edge to draw a line that goes through the data. I've gone ahead and I've completed all of the points. I have 1 8, 2 16, 3 24, 5 40, and 7 56. And again, I'm going to start at 0. I'm going to do the best I can to use a straight edge to run right through all those points with my line. Our last part on page 266 is to plot a point to show Andy's earnings for 5.5 hours. So remember, you know our rule here was to simply multiply by 8. So I can take 5.5 and I can convert it into a mixed number, which is going to give me 11 seconds. And I can multiply that by 8 over 1 to give me 88 over 2. And I know that 2 goes into 88 44 times, so that 44 is going to be dollars. The other way I can do it is take a look at my graph, and I can think about this as being 5.5, and I can run it up here and see where it hits the line, and that hits it right at 44. So I know that an easy way to check it maybe, or maybe you see the graph as being easier than doing the multiplication and division. So that's up to you the way you want to solve these problems. Here we are on page 267. I'd like for you to take the next couple of minutes, pause the video, and go ahead and solve that, knowing that Frank types 45 words per minute. The rule is words typed is equal to 45 times the number of minutes. So go ahead and complete the chart, figure out the ordered pair, and then come down here and plot the points. And then there are 2 questions that you could either use the graph to solve the problem, or you could use the multiplication once you figure out the rule, which they tell you right up here again is 45 times the number of minutes. So go ahead, stop the video, complete this page, and then I will flash up the answers for you. Here we are on page 267, and if you did this correctly and you knew that 45 words per minute, words typed in 1 minute is going to be 45, 2 minutes is going to be 90, 3 is going to be 135. They gave you 225, so you had to divide that by 45 to get 5. And then the last one, you multiply 6 times 45, you get 270. From there, you're going to be able to come up with these ordered pairs, and that will help us to figure out this graph here. You can see if that arrow continued down there, it would go right through that origin. And the last couple questions that are down here, plot a point to show how many words Frank could type in 4 minutes. How many words could he type? The answer is 180, and again you could do that by multiplying 4 times 45, or you can go in this chart and go up 4 and go up till you get to that 180. And for this one here, it's going to be 20. Each line is worth 20 in the increments. And then the last one, how long would it take Frank to type 200 words? So you could take 200 and divide it by 45, and you're going to come up with 4.5. Or you can start over here at 200, run all the way across until it hits the line here, and that's going to take me here, and I'm going to come down there, and that's going to be approximately halfway in between, so you get 4.5 there. So again, a couple of different ways to solve these types of problems. The summarizer for today, we're going to use this same example with Frank and typing 45 words per minute. Would you use the table, the graph, or the rule to find out how many words Frank could type in 12 minutes? Go ahead and share what you would do and explain how many words he could type in 12 minutes. Now that you're finished 7-Eleven, you need to go ahead and complete Math Boxes, page 268, and then head out into the crate for HomeLink 7-Eleven, which does exactly what we just did, working with the rules, the tables, and the graphs.